Hello, welcome back. In this segment, I want to apply the rules of disjunction to an interesting problem, associative property of R. But the proof itself is quite involved if we apply only those two rules we talked about. Rules for introducing an R, like the disjunction introduction, and then rules for eliminating the R. So we wanted to prove that P or Q or R is same as P or Q or R. Okay, so this is the premise and this is the conclusion. Assuming P or Q to be true, because this is an R statement. We don't know which one is true, but we can start assuming this is true. And we should be able to prove this is the case. I'll start with P or Q as a subproof. And now again, I have to split this into another subproof for P. So now, once I know P is true, right, I'm allowed to add anything I wanted to the statement. So I can add Q or R. What is rule I'm applying? I'm applying or introduction to line number 3. So let's check the proof to make sure we are okay. No errors found. Good. That's good. Let's continue further. What have we achieved? We have done a small portion of the proof. From P, we were able to show P or Q or R. That's what we did. Let's go ahead and start another proof. Okay, for Q to be true. If Q is true, we need to be able to show P or Q or R. Okay, since Q is true, we are allowed to add anything we wanted. Let's go ahead and add an R to it, which is again R introduction to line number 5. And again, we can add anything. Since Q or R is true, we can add anything. And so I'm going to add a P to it. It's R introduction to line number 6. Okay, let's check the proof to make sure there's no typo, nothing. Yeah, this is good. So far, we are fine. Next thing is we need to pay close attention now. We have arrived at P or Q or R here, also here. Let me circle it. Okay, with assumption P, also with assumption Q. And we have a higher level assumption P or Q is true. Now we can apply OR elimination. I will insert a new line to the parent. What am I going to climb? I'm going to climb P or Q or R. This is because of OR eliminations. Line numbers 2, 3 to 4, and 5 to 7. Okay, so let's see. No errors found, but you have not reached the conclusion. Why do we have not reached the conclusion? Although we have P or Q or R on line number 8. The reason is that we only proved assuming P or Q to be true. Now we need to repeat for R. Okay, so it's getting lengthier, and as I warned you earlier. Now we need to consider a subproof for the case of R. So R being true, we can definitely go ahead and add a new line. We are allowed to insert anything we wanted if R is true. So I will insert, okay, on line number 9, insertion to result in 10. And since Q or R is true, I'm allowed to add another thing in the front. Okay, I'm applying R introduction rule to line number 10. Okay, now pay close attention. We got when P or Q is true, we were able to arrive at P or Q or R. That's one part. And then when R is true, we are able to arrive at the same P or Q or R. But overall, if you combine these two, right, this is part of the assumption here. P or Q or R is the assumption, okay, which is assumed to be true. And if this is true, we got P or Q or R. If this is true, we also got P or Q or R. Okay, now we can apply elimination of R to complete the proof. Let's do that. All I have to do now is add a line to the parent of this subproof and complete it with this. The reason being, I'm eliminating an R from line number 1 and 2 to 8, 9 to 11. Okay, let's see whether proof check is happy. Yeah, we are done. Congratulations, the proof is correct. This is long and tedious, but it's a repetition process, right? All you have to do is just assume this is the assumption, right? This is the assumption, but we don't know which component of the assumption is true. So we need to split it into two parts. This is the part 1. This is the part 2. In both cases, we were able to arrive at P or Q or R. Okay, and then you can dive deeper into each component. For P or Q, how did we arrive at P or Q or R? We split it again into two components. And we arrived at the same conclusion in both cases. So this is how you would split and organize your proof. All we have done in this proof is using the OR introduction rule or elimination rule. Okay. These are the two rules of disjunction we have used to prove the fact that from this direction, we can go here. As a homework, you can take this direction. So to show that OR is associative. Okay, that's all. Thank you very much for your attention.